In the previous video, we constructed this structure with the shown geometry. In this video, we will apply loads. Our example code specification for the design load requires us to increase the dead loads by 20%, so we'll do that using a custom material with modified density. Let's quickly change the units to feet and pounds to match the given units for the structure. We'll navigate to the Material Types browser, right-click the concrete layer, then choose New Material, and we'll name it Slab Material. We'll enter and adjust its specific weight value to apply a 20% increase in the dead load and a 50% decrease in the live load as per our design code specifications. In the Structure browser, we'll right-click on the slab components, then choose Select Components. Then we'll switch to the Properties browser, scroll down to Element Group Specifications, and switch the material to the newly created slab material. Next, we'll start refining the mesh of the components around the column we've chosen for removal. Let's start with the three neighboring columns. We'll navigate to the Properties browser and choose the mesh dimensions as 30 by 3 by 3. Let's select all the edge beams and change the meshing to 10 by 1 by 5. For the midspan girders, we'll change their mesh to 15 by 1 by 5. Previously, when we applied the check integrity command, ELS automatically generated the mesh after removing the overlapping elements between the girders and the slab, and between the slab and the columns, then locked the mesh. To unlock it, we'll select the slab, select all elements from the Properties browser, then click the Additional Tasks menu, where we'll choose Remesh selected elements. We'll redefine the mesh as 30 by 30 by 1. We'll repeat the same process for the neighboring slab. Now, from the Structure browser, we'll right-click the Level 1 layer, choose Copy, then right-click the Structure layer, choose Paste Level Array, then enter 3 as the number of levels. Now, it's time to create our loading scenario for dynamic analysis. We'll navigate to the Loading Scenario dialog from the Pre-processing browser and create a new dynamic stage. We'll choose the type as Dynamic Concentrated Load, set the time step to 0.01 and step division 10. This means our analysis time step will be 0.001 seconds. We'll now create a Demolish scenario for our column. We'll choose the Demolish Scenario Pre-processing action, create a new group. Use clipping to remove the back section of the building from view in order to easily select the column's elements. Once the elements are selected, we'll press Enter and change the Demolish action to occur at the beginning of Stage 2. Our final step will be to adjust the material properties for the normal steel material used. We'll switch the project units to kips and inches, and we'll double-click the normal steel material from the Material Types browser. We'll enter 60 KSI as the yield stress and 1.25 as the ultimate to yield ratio for an ultimate stress of 75 KSI. In our next video, we'll run the analysis and look at the results.